Welcome to the bright light spectrum. Another mystery involved the emission spectra observed from energy emitted by atoms and molecules. You'll notice that this here is one of our gas discharge tubes that we've seen in class. This one is actually for neon. And we looked at the bright line spectrum. You do not necessarily observe a continuous spectrum as you might get from a white light source. Instead, you will only get a line spectrum of particular wavelengths you will see. So here for sodium, you will only get one wavelength with the color of yellowish green. Here you'll notice for hydrogen, we have two different wavelengths of purple or violet. One here with a blue and then another one here down at the red. Electrons absorb energy as they move to higher energy levels. This is also known as the excited state. This excited state is temporary and is very unstable. What happens is electrons are negatively charged, and therefore they are attracted here to the nucleus because it is positively charged. They will eventually fall back to their ground state and give off energy, and when they give off this energy, it comes to us in the form of light. Light, or the color of the light, is determined by the amount of energy lost by the electron when it drops back to the energy state. So in an example, some possible ways an electron can fall back to ground state here is if we happen to have an electron that drops here from the violet state down to the violet blue state, it will have dropped just one energy level. If a violet color would drop back down to green, that would have been 1, 2 energy levels. The bright line spectra here, as we can see, for hydrogen, basically is very unique to that particular element. When we're looking at each element individually, you'll notice that the colors and the lines will be slightly different for each one. It's very similar to a fingerprint. So if we want to know what makes up a particular star in a far, far away galaxy, we can use a spectra to find out exactly what it is and what it looks like. So if we know that we have something that comes back with two purple lines, a blue, and an aqua color and a red, we would know that that star is made of hydrogen. So one of the really cool things is if we happen to have an unknown mixture down here and we look at all the lines and where they are located on our spectra, and we know that we have these four particular gases, we would look to see where the lines match up. So here we have four distinct lines that match our unknown. These are for gas A. These other three that don't match gas A, but they do match identically to gas D. So our unknown mixture is a mix of gas D and gas A. So let's check some understanding. Each line on the visible line spectrum represents which electrons jumping to a same excited state or energy level, electrons falling back down to the ground state from the same energy level. Could it be electrons jumping to multiple excited states or energy levels? Or would it be electrons falling back down to their ground state from multiple energy levels? Keep in mind, we learned that to get light, electrons need to fall back down to their ground state. The color we get depends on how many energy levels it must fall to get back to its ground state. So let's check our understanding again. So here's another unknown mixture of gases. What we need to do is to find out what gases line up with the individual lines on our unknown. Here we have three lines that match beautifully to gas D. So that leaves 1, 2, 3 lines that do not match gas D, but they must match one of the others. And if we follow the line up, we notice that gas B has all three of the gas lines that we did not see with gas D, so therefore this would be a mixture of gas D and gas B.